Good morning to everyone, and thank you for being, well, not here, but today just logged in. When I was asked to make this presentation, I wondered what I could tell you about my personal experience after all these years of partnership with the SCCER-FURIES. What I've learned the most from all you, of whom some have become friends. So, I'm going to tell you what my vision to date has become as an old utility guy, and for sure thanks to you, about the role of the monopoly of the distribution grid in the energy transition. I'll be back to you right after.
Well, let's go over. In 2014, Romande Energie joined the SCCER-FURIES board without too many specific objectives. But it's a trend, and being a member is undoubtedly smart. It's 2014, and everyone is talking about smart grid without really knowing what it really means. The question of the governance of a collaboration in such a vast research project quickly arises internally, and above all, how to transfer the lessons learned to the operational level. At the end of 2015, the prospects for co-creation with the various research institutes were such that Romande Energie entrusted me with the responsibility of leading all of its partnerships with the academic world. In 2016, a turning point was taken. A task force was created with the three DSOs represented on the board to prepare phase 2 and the research activities for demonstration. I therefore see an opportunity to give direction to our own roadmap by creating a link between the work of researcher and the development of our vision as DSO at the center of the energy transition in Switzerland. Today, after many obstacles and despite COVID crisis, the technical infrastructure of the demonstrator has been completed and allow academic activities to be carried out by the end of the project in 2022. This collaboration has already given rise to several other projects supported notably by the SFOE, which are in progress or about to be launched. Many of the people listening to me today have created their careers directly or indirectly on technology and the progress it brings or brought about. So no wonder we so readily believe that technology is the response. But to what is the question? Probably not by trying to do the same things we do today, just in a cleaner, more efficient, more economical, more smart way. But by doing them differently to cover redefined needs. It's difficult to be consistent in our choices and our actions without having an overview and therefore a more systemic approach for an energy, environmental, economic and political point of view to create the society that we wish, which is certainly carbon-free, but above all, sustainable. What are the challenges that await us? What is electrification? What do people really need? Without visibility of the impact of our choices, we risk contributing to the emergence of a green economy based on the same principles that have led us to where we are now. A promise of a better tomorrow like that of oil in the past. But the energy strategy and the environmental or climate policy depend on different political institutions, which implies a need for coordination. The Energy Strategy 2050 involved mainly the public sector, means infrastructure, while the climate policy involves mainly the private sector, for instance, buildings and transport. Achieving the objective of the two policies creates an overlap between the responsibility of the public sector and those of the private sector, which requires cross-sectoral coordination. The public sector has the potential to accelerate private sector investments, and that's a new role for public utilities. The role of power grid in the energy transition is to make possible the transfer of fossil energy needs for heat and for transport to the electrical agent. By adapting, on the one hand, to the massive integration of renewable energy resources while taking into account the necessary changes in consumption patterns. To do so, the grid, which by itself is not really intelligent, but interact with the ecosystem formed by grid users such as energy consumers, producers, storage asset owners, microgrids, or energy hubs, and other public utilities such gas, water, road, and waste. It's in these interactions that intelligence resides. The smart grid being therefore an overall notion that links both public service activities and those of private sectors. This is where a disruptive governance model must emerge. To accelerate the energy transition, we need to move from a hierarchical and compartmentalized and uncoordinated system of systems to a distributed ecosystem where the various actors of the public and private energy sector interact efficiently with end user, individuals, companies, and public authorities. This disruption of the current governance model implies a digital transformation that makes the necessary intersectoral coordination possible. A digital transformation made possible today by the sharing of data from administrations and public utilities with other actors within an ecosystem based on open governance. We would then witness the emergence of a new notion of public utility, that of data, a data distribution network within an ecosystem for the benefit of all end users and all free market players, giving visibility to investors and political authorities. But the ecosystem is not just about rethinking the use of data. It's also necessary to rethink how the systems are operated and how they interact. We are moving towards more decentralized systems, but their interconnections will not always be possible at the local level and will in turn require re-centralization and perhaps new networks. It's therefore a question of moving towards an ecosystem where we no longer centralize what is necessary for management and control, where intelligence, data, and analytics are distributed, where local framework conditions define the emergence or not of new technologies, where the financial flows of business models are distributed among several players, and finally where services dematerialize the notion of ownership. We are moving towards a mechanism where the district is at the center of energy planning, where peer-to-peer exchanges are the driver of changes in consumption behavior, and where overall management is no longer the responsibility of a few operators, but a multitude of participants. We use more, we buy less. Let's say an ecosystem. Let's say an ecosystem where coordination is achieved by data instead of by structures. It's coordinated by data and not by organizations. It's also being able to choose how and when to consume for individuals, companies. It's also being able to invest or let invest in the right infrastructure at the right time for public authorities. It's also being able to measure the effectiveness of incentive or restrictive policies for cantonal political authorities. What could we now expect from academics? Well, a technological approach adapted to the distributed operating mode of the desired ecosystem. Computing power is mainly used locally, means at grid edge. More analytics and AI for more predictive than reactive management, means federated versus centralized. Real-time for decentralized reflex actions and less centralized bandwidth requirements. An approach that promotes the emergence of peer-to-peer exchanges and the circular economy. Technologies designed to be financeable through the as-a-service business models, where the multitude of users contributes to the financing of investment. Well, finally, as a final quote, I'd say, the transition will be political or not at all, will require massive participation at the core of a distributed system based on an open data governance and societal transformation.
Okay, this is only a personal point of view, but the subject of open data governance is a true rising theme in the debate. Of course, we are not talking about sharing personal data, but about making the use of advanced analytic and artificial intelligence algorithms accessible to all those who are responsible for implementing policy decisions, to all those who are looking to invest, and to all those who are able to offer the suitable solutions or equipment. Therefore, coordination between political authorities and public or semi-public companies is necessary to create this kind of distributed ecosystem. But the best technology or solution, if based on the traditional business model, cannot be rolled out in the current context. Consequently, probably only models from the digital or circular economy will be suitable to harness the microeconomic stream in it. Finally, closer collaboration with the human, social, and economic sciences would be helpful to ensure that the engineering sciences can provide the right answer to the right question. This should now be our focus for all our further collaboration. So, thank you very much for listening.